This video is on factoring quadratics. I'm going to start off by explaining what factoring is. Factoring is rewriting an expression. So we will rewrite an expression as the product of its factors. Factors are what multiply to get to a number. So the factors of 20 are 1 and 20, 2 and 10, 4 and 5, because those numbers will multiply to 20. So if we're factoring anything, we want to rewrite it as the multiplication of what actually makes it become that expression. So an example that you might see is if you had negative 2 parentheses x plus 2 close parentheses, 3x minus 5, close parentheses. This is actually factored form because this is a multiplication of factors. When you have things squished together, like this negative 2 squished together to that parentheses, that's multiplied to it. There is no sign in between these two sets of parentheses, so this is a multiplication. So in order to rewrite it as an expression in its factored form, the original expression was something different, and if we were to distribute this back through, we would actually get the original form. So we're going to be rewriting our problems into something that looks similar to this. It won't always look like this, but it'll look similar to it, as in it'll be multiplication of things. The next term we're going to talk about is the greatest common factor, or GCF. The greatest common factor is the largest number and or, does not have to be both, but it can be the largest number and or the largest letter that each term can be divided by. So the reason it's called the largest, greatest, means it's going to be the largest. Common is because it has to go into each of the terms, each term. So if there are 8 terms, it has to go into all 8 terms. Factor, because it can be divided by it, because the inverse of multiplication is division. The GCF is actually always the very first thing you do. It is always the first thing you look for. You have to find the greatest common factor before you factor the rest of it, because if you end up having factors that are common inside of your parentheses, that means that there is more factoring you can do. And you always want to find the GCF first. So these were vocabulary words. I'm actually going to highlight these in yellow so that we can see them again. They're vocabulary, and I like to highlight vocabulary in yellow. Now this next part is the directions will actually say to factor completely. These will be the directions that you see when it asks you to factor. Factor completely. So I'm going to highlight these in pink because this is the directions that we're going to follow. Factor completely. Now I have a chart here that it has different amounts of terms that we could have. The part up at the top of the chart is a GCF because that's always the first thing you look for. Once you have factored the GCF, you can actually determine how many terms are left inside the parentheses after you factor the GCF. Because the amount of terms determines which method of factoring you can actually do. So after you factor your GCF and you're left with two terms inside the parentheses, you will look for, for this course, you will look for a difference of squares. A difference of squares is when you have two perfect squares. So you have two terms. You're going to have two perfect squares with a subtraction. So a perfect square is anything that is a number times itself or a letter times itself. So if we think about 3 squared is 9. So 9, and then if I talk about x times x is x squared. This is only one term. This is called a monomial, one term. I need to have two terms to have this. So I have to have a subtraction sign because it says difference. So 9x squared minus, if I want to do another perfect square, if I think about 5 times 5 is 25. So a difference of squares would look something like this. Two terms, that this entire term is a perfect square, this entire term is a perfect square, and I have a subtraction between them. Later, when you are learning more factoring, two terms, you might also look for a difference and a sum of cubes, but in this course we're not going to be focusing on that. We're just going to be focusing on difference of squares. If you have three terms after you factored out your GCF, you will actually try and factor it further by using guess and check. What this is you are actually just trying to look at the numbers and see which ones would multiply back to give you the original problem. So these have steps that I will show you, but it's guess and check. There are other methods to factor three terms. This is the method I'm going to show you today. And finally, if you have four terms after you have factored your GCF, you're going to use grouping. Other people might call this the box method. It's grouping. You're going to group sets of two terms that have something in common and factor their GCFs. So you've already factored out the original GCF, that's for the entire problem, but on four terms, you're then going to group two terms together, factor out the GCF of those two terms. You're going to have another group of two and factor out the GCF of those two terms, and then we'll end up having our answer. So, some important information is when you're factoring, sometimes you can only factor the GCF. Sometimes you can only factor the GCF, and that's okay. I'm going to put that, and that's okay. So you might get to where you can factor out the GCF, and you have three terms left. But there's nothing that works for these three terms, and that's okay. Your answer will be from your GCF. So you'll have your GCF on the outside and the three terms left inside the parentheses, and that's okay. You might get your GCF out, and you might have two terms left, and it's not a difference of squares, and you cannot factor it further, and that's okay. So your answer will have your GCF on the outside and your two terms left inside the parentheses. However, if you cannot factor anything, so that means including not even the GCF, you can't even find a GCF, You cannot find a greatest common factor. It is prime. A prime number is a number that can only be multiplied by 1 in itself, so its factors are 1 in itself. So if we think of the number 7, the only numbers that can multiply to 7 are 1 and 7. So if you are factoring and you have no GCF, that is okay if you don't have a GCF. Your GCF can just be 1, and you have 3 terms. But nothing can factor from the 3 terms either. So your GCF was 1, and nothing else can factor. Then that problem is prime. However, this first statement said that sometimes you can only factor GCF. So if the GCF was anything other than 1, then it is factorable. It will not be prime. It will not be prime if your GCF is anything other than 1. So this chart is explaining what methods you should use in determining when you're factoring, so that you know how to factor each of these sets.